So schools don't typically teach us how to take good notes, which is crazy because it's a difficult skill to learn, especially if you're taking different subjects like math or science, which is very technical, versus literature or history, which is very text heavy. So we've created multiple note-taking tutorials in our Ultimate Study Skills series, and this video in particular will cover how to take better notes for any subject. These frameworks come from How to Become a Straight A Student by Cal Newport. He was a top Ivy League student, and then he went around interviewing other top students around the country. Now he's a professor at Georgetown University, so he speaks from multiple perspectives on this note-taking topic. So let's dive right in. In general, we have two types of classes. First, we have the non-technical classes like literature, history, or poli-sci. These classes usually involve long, dry reading assignments. Then we have the technical classes like math, science, economics. These usually involve problem sets, calculations, code, and equations. So let's start with the non-technical classes, right? The three-part framework here is what Cal Newport calls QEC. Question, evidence, conclusion. So the goal is to make notes that clearly state QEC for every big idea, but it's not as easy as it sounds. The good news is that a lot of professors will teach information in this framework. Like they'll pose a question, and they'll walk through some evidence, and they'll reach a conclusion, and then they repeat this process over and over for the rest of the lecture. And the bad news is that they don't tell you which info is the Q or the E or the C, right? Some professors just love to ramble and they go off topic, and then we're left trying to figure out what's actually important. Sometimes the professors won't even state the questions, so be sure to put a star to remind yourself to come back and figure it out because it's probably going to be a test question. Sometimes they'll just hint at a conclusion, but they won't right out say it, so it's up to us again to figure that out. All right, so let's do a quick example here because sometimes the conclusions are not exactly straightforward. Let's say that the professor poses this question: who is the greatest basketball player? So I'll write that as the question and then be on the lookout for evidence and conclusion. So during lecture, the professor might give a simple conclusion like Michael Jordan, right? And the evidence might be several points highlighting how many championships he played or how he changed the culture of basketball or something. But it's not always going to be that simple, right? Because the professor could say that it depends, or you might have multiple reading assignments that all look at different bodies of evidence and they all arrive at different conclusions. So for example, the conclusion might depend on which analysts you ask, or it might depend on what stats you're comparing, or what about LeBron James? Sometimes a question can have complex conclusions or multiple conclusions, and you have to be able to group together which evidence supports which conclusion. So make your QECs as clear as possible. Another quick tip here is if you're using an app with toggles like Notion, then one thing you can consider doing is nesting your conclusions and evidence under toggles to make your review sessions more efficient. So if the conclusion isn't obvious, then you gotta do whatever it takes to figure it out, right? Ask questions during class to clarify, or ask the professor after class, or go to office hours, or ask your friends. But you wanna make sure that you complete as many QECs as possible during or immediately after class when the information is still fresh in your head. Because when it comes time to review for the exam, you want a study guide that's easy to review, right? You don't wanna be spending more time trying to relearn or figure out what you wrote. All right, let's switch over to the technical classes. Cal Newport doesn't explicitly state this framework, but we'll call it the PSA. Problem, steps, answer. So he states that the key to taking notes in a technical course is to forget the big ideas and record as many sample problems as possible. I don't agree with this actually. I think that big ideas are very important in technical courses. I think that if you can forget about all the numbers at first and just focus on understanding the math in words, that will make it much easier to learn. So for PSA, your professors will most likely give you the sample problems and answers, so be sure to save them or print them or write them down. But that's the easy part. The hard part is writing out all the steps on how to solve those problems and annotating those steps. So a quick example here, I'm writing out the steps that lead to the answer, but I'm also annotating those steps, right? I'm taking notes about what steps are being used, when they're being used, and why they're being used at that time. Because I want to understand the math or the science, not just in numbers, but also in words, right? So literally writing out the explanations if I need to, or using arrows or bolding important parts. So some professors move really fast, and if you don't understand, raise your hand and ask questions, especially to clarify the annotations. If you need to, then put a question mark and maybe come back later, because recording the steps without the annotations is just useless. Right? We don't want to learn technical courses by rote memorizing the steps. We want to understand when to use which steps and apply it to any problem on the exam. Now, most beginner students don't even have a framework for taking notes, so the QEC, the PSA, these are really good places to start. However, if you're trying to become a top student, there are some limitations to these methods. In particular, they mainly facilitate learning information in isolation. Yes, you might have the QECs for a class, but did you take time to synthesize multiple QECs together and form the big picture? Yes, you have the full PSAs for every sample problem, but what if the variables and steps were slightly changed? Do you understand the reasoning behind the steps enough to nail those curveball questions on the exam? Because when we evaluate or synthesize information in this way, it gives us a deeper understanding, and that goes beyond the QEC or the PSA method. So we do have more advanced note-taking videos, like the mind mapping one, for example, but I'd recommend that before you go there, to check out this video right here, because it covers a framework on how to achieve deeper understanding of what you're learning, which will ultimately make your notes more concise and more effective for review. I'll see you there.